Hi guys, welcome to the channel. Today we will be doing functions. This is a Regents review, so we won't teach too much into it, but it's more like a review. So I want you guys to test your knowledge on number 1 and number 2. Pause this video, take at least 3 to 5 minutes and answer these 2 questions. The first one says, is this a function? Why or why not? Then number 2, does this represent a function? Test your knowledge, see if you know your answer, write your answer down, then you can start playing this video again. I won't go over the answers until we go over the lesson. Then you guys will see if your answer is correct or if it's incorrect. We know a function assigns each domain element x to only one range element y. So whenever you see the word domain, think of the x-axis. And when you see the word range, you're thinking of the y-axis. Then we talk about the vertical line test. To demonstrate this, we'll do the vertical line test. A graph represents a function if any vertical line passes through it at most once. So if your line that you draw through your graph intersects the graph only one time, then it is a function. If it's 2 or more, it is not a function. And of course, we're going to do some examples. Okay. We won't read the strategy because we're going to do it over and over again. I'll do the guided practice. There's independent practice on the back here, but we won't do those. We're just going to do the guided practice, and then we do other examples of a function. Okay, so this line right here, let me put it in green as well, because the other graphs are in green, so you can differentiate those. So this is your graph. Good. Let me see if I zoom it in some more closer. So this is where we're going to use our vertical line test. So if you want to use straight hand, it's fine. If you want to use a graph, it's fine. You should be provided a graph, so you can use that as well. So we know for our graph is the green line. For a vertical line test, vertical meaning you're going from top to bottom. So you're drawing a line from the top to the bottom. You choose anywhere on your graph that you want to do this vertical line test. I'm going to choose the right side. I'm going to draw my line from top to bottom because this is vertical. Where it intersects, my blue line intersects the green line right here. And it only passes through only one point. This is a function. Let's do number 2. So again, the green line is my graph. Choose any side that I want to draw my line through. I'll choose the left this time. My blue line intersects the green line or the graph right here. So where my orange line is, that is where the point intersects, and it only passed through one point, so it is a function. Okay. Number 3, this is a parabola. Quadratic equation will cause this to shape this way. Choose any side. I will choose the right side, where my blue line again intersects, passes through the green graph. That is my point. If it's just one point again, it is a function. Then number 4 is a bit tricky. So if you turn it this way, it will look like a parabola, but it's shaped differently. Same idea. As long as it's a graph, choose a side that you want to draw your line through. Drew my line on the left. My line intersected through here, and it also intersected through here, which simply means If it's 2 or more points that it passed through, it is not a function. So in this guided practice, we had 1, 2, 3 functions and 1 being not a function. And this is how you would identify a vertical, or you would identify a function using the vertical line test on a graph. Now, this is question similar to what we just practiced. This is the Regents question, and this was year June 2025. This is question 19, and it says 4 graphs are shown below. This is graph 1, 2, 3, and 4. Which of the graphs represents a function? So if it's a graph, we know that we want a vertical line test. So we're drawing a line from top to bottom through our graph, and it only needs to pass through 1 point. So let's test to see. So we're going to draw our line anywhere on our graph. Boom. Where our blue line intersects this graph, which is here, and when it passes 1, we know this is possibly a function. Okay. Our next graph is, let me use green. So of course, this is your graph. Let me do this one as well. This is also your graph. And this round piece is your graph. Okay. Do a vertical line test. Draw a line top to bottom anywhere on your graph where your line intersects the graph, given graph. And if it passes again through 1 point, it is a function. So we know B and A are functions. It's try C and D. Draw a line through your graph. This would not be a function. And I will show you guys in another Regents question example. But this would not be a graph because on your Y, on your X, it's only hitting 1, right? You have 1 value of X. However, it can hit several Y values. You only always want your X to have 1 value and not 2. So this X and this X are different, but they both share a Y. This would not make it a function. If you have X, Y, so one, same example, but let's make it a function. If this has and this has their own, so if a X has its own value of Y, it is a function. So in this case, this one value of X, it would be sharing several different values of Y, potentially. So this would not be a function. For D, do your vertical line. It intersects here and it also intersects here. And again, if it passes through 2 points, it is not a function. So your answers, or your answer would be A and B. You look for A and B, which is number 2, and you circle it, and that concludes this question. All right. Same idea, right? Same exact idea. So our entry slip had number 1 and number 2 here, which I'm going to do these examples and then you're going to do the entry slip questions to verify if you actually got it correct or if it was incorrect. So when you're given a function or anything looking like this, we know the first number is x, y, x, y, x, y, x, comma, y. We know this. If you cannot visualize this to see how it's set up, simply, it's your test. Mark it up if you need to. You're gonna draw it out. So you're gonna say X and Y. So we see our X's are 0, 1, 2, 3. So we start at 0, 1, 2, and 3. 1, 2, 3, 4. So we see 1, 2, 3, 4. Now, for our first pair, we see it's connected to 0, 1. Second is 1, 2. Third is 3, 2. And the fourth is 3, 4. If the value of X, as I showed you guys on the example on this side, if the value of X, if single X's are connected to only one value of Y, it's not. If a single X has its own value of Y, like we can see here, it is a function. This wouldn't be a function because they're basically sharing the one person. To make it a function, you need your own person. So for this example, all right, and then the last one that we're going to work on for this example is January 2026. So this is this year, right? So the question says, which graph below represents a function? So of course we test each graph. Graph again, do a vertical line test. It doesn't matter, as long as it's a graph, do a vertical line test. So you realize this passes through one point, so this could be a function. All right. Choose this. Oops. We highlight the points that it passes through. This would not be because it passes through 2 points. Perfect. Choose the ones in the middle, not the ones at the end. Because if we do the ones at the end, it's only going to give us 1 point, and we're not sure. We have to cover the whole surface of the graph. So we go in the middle, draw the line. Again, if it passes through 2 or more points, it is not a function. And then the last one, this one, vertical line test, passes through 2 or more points, not a function. So our answer would be 1. Now remember, in the beginning I said to you guys that we're going to do an example of this where, yeah, this one, these are similar. So let me see if I can find a blank sheet so I can put them side by side. There you go. So we have the same question, right? This was the original one that we did in the beginning, first example, Regents question. And I remember I stated that I'm going to show you one that's similar to show you why it would not be a function. Both of them are going vertical. And as you can see here, while it's on one value of X, it potentially can have several values on Y. In this case, if we label this as 1, 2, 3, and then this being 1, we can say it would be 1, comma 1, 1, comma 2, 1, comma 3, right? It would look something like this in a table form if you wanted to visually see it clearer. So we realize that the value of X, one X is connected to 2 values of Y. You never want that. You always want one X to have its own Y, and the other X to have its own Y, never sharing. So this wouldn't be a correct answer. So now that we did some examples, we did some Regents questions, let's go back to the entry slip for you to test your knowledge. So same idea, we'll label X, comma Y, X, comma Y, X, comma Y. Draw your table if you need to visually see it. 1, 2, 3, 1, 2, 3, 4. first pair says 1, 2, then 2, 2, and then 3, 4. This would not be a function, because again, we always want the value of x and y to have their individual people. 1, 2, 3, 1, 2, 3, 4. So to make it a function, we could say 1, 2, 2, 3, and 3, 4. This would be a function. Then for the second entry slip, testing your knowledge, does this represent a function? So the green is our graph. We draw a line through our graph. If it passes again through 2 or more points, then it is not a function. So both examples given or questions given are not a function. I hope you guys understand it. If you don't get it the first time, definitely rewatch the video, do some more practice. Because all in all, if you follow the steps that I've given to you, you will be completely fine and you will be less stressed. I'll see you guys in part 2. Part 2 will be a continuation of this worksheet. So for a function, there are different ways you can identify a function. The one that we did today was through the graph. For part 2, to identify, we're going to do function family and then by the patterns in a table.